Morning to everyone. I am Navya Devi from Physical Science Department. Today I am here to discuss on the topic oscillation and waves. Oscillation and waves. First, oscillation. When an object or a particle moves back and forth repeatedly for some duration of time, it is said to be oscillatory or vibrating motion. Example, Tanjore dancing doll, heartbeat, swinging motion of a bird's wings, pendulum clock, etc. are examples of oscillation. Next, simple harmonic motion. Simple harmonic motion, it is the oscillatory motion in which a particle acceleration or a force are directly proportional to its displacement. That is, F is equal to minus k into x, where k is the force constant. Here the negative signs represent that the force, that is restoring force, that acts opposite to the direction of displacement. Next, angular simple harmonic motion. It is the auxiliary motion in which here the torque for angular acceleration is directly proportional to the angular displacement. Its direction is opposite to that of angular displacement. That is, torque is directly proportional to theta. To remove the proportionality constant, we multiply a symbol k. It is a restoring torsion constant. The negative sign represents that the force is acts opposite to the direction of displacement. Next, linear simple harmonic motion. A linear simple harmonic oscillator, it is a linear periodic motion of a body. A best example for it is a spring mass system. Here the restoring force of oscillation is always directed towards the mean position and its magnitude is directly proportional to the displacement from the mean position. That is, we get the equation F is equal to minus k into x. By applying Newton's second law, we obtain the equation d square x by dt square is equal to minus k by m into x. Next, types of oscillation. There are 5 types of oscillations. First, free oscillations, damped oscillation, maintained oscillation, forced oscillation, and resonance. First, free oscillation. In this oscillation, the oscillator oscillates with a frequency which is equal to natural frequency of oscillator. Here, the amplitude, frequency, and the energy of the vibrating object remains constant. Example, vibration of tuning fork, vibration in stretch string, oscillation of simple pendulum, oscillation of spring mass system are all examples of free oscillation. Next, damped oscillation. In this oscillation, due to the external friction, here the amplitude of the frequency of the wave goes on decreasing and the energy of the oscillator is used to do work against the resistive medium. Here, example for damped oscillations are oscillation of pendulum, in electromagnetic oscillation in tank circuit, oscillation in deadbeat, ballistic galvanometer, all examples of damped oscillation. Next, maintain oscillation. In maintain oscillation, the external energy is supplied to the oscillator by the external circuit in order to avoid the damping. Example, vibration of a tuning fork getting energy from battery or from external power supply. Next, force oscillation. In force oscillation, an oscillator is driven by external periodic agency is to overcome the damping. Here, in this, initially the oscillator operates in natural frequency and later on it vibrates in the presence of external periodic force. Example, sound boards of stringed instruments. Example, that is, we can say that a sound from guitar. Resonance oscillations. It is a special case of force oscillation. Here, the frequency of external periodic force which matches with the natural frequency of the vibrating body. That is, example of it is breaking of glass with a sound. Next, waves. What do you mean by waves? Waves is a way of transmitting energy. It is a disturbance in medium which carries the energy and momentum from one point in space to another, which doesn't require any transfer of medium. There is also some waves, that is a mechanical waves, which needs a medium to travel, that is sound and water waves. A light, sound, and phase are the best examples of wave. Characteristics of wave motion. First, for a propagation of wave, a medium mass possesses both inertia and elasticity because it decides the velocity of a wave in that medium. Next, in a given medium, when a velocity of a wave is always constant, but whereas the constitutional particles in that medium moves with different velocities at different positions. Next, waves can undergo reflections, refraction, interference, diffraction, and also polarization. Transverse waves. In transverse waves, when an oscillator vibrates in y-axis, then the wave motion will be in x-axis. That is, oscillation is perpendicular to wave motion. That it is the transverse wave motion in which all points on the wave oscillate along the path at right angles to the direction of waves. Bands. Example of transverse waves are surface ripples on water, seismic waves, and electromagnetic waves. Next, longitudinal waves. In longitudinal waves, the oscillator oscillates in y direction, but its wave motion is also in the same direction. That is, the oscillation is parallel to the wave motion. Then here the vibration of medium that is parallel to the direction of wave travels and displacement of medium is in the same direction of wave propagation. Example of longitudinal waves or longitudinal sound waves. Sound wave is a best example for longitudinal waves. Today in this video, we have seen a lot of information about both oscillations and waves. We have seen what is oscillation and its 5 types of waves, and also the 2 types of waves and in clear and detailed manner. Thank you.